Welcome. So in this video we will learn how to fractionate different fraction of milk nitrogens. So Roland has given, that is the full name is H.J. Roland, has given scheme to fractionate different nitrogen fractions of milk that we will study in this video. So H.J. Roland was the person who has given a scheme to fractionate different nitrogen fractions of milk that we will study today. So in addition to casein and whey proteins, milk contains two other groups of proteins or proteins like material, the protease peptone and non-protein nitrogen. So Roland observed that when milk is heated to 95 degrees Celsius for 10 minutes, if you heat the milk, that is if you boil the milk, 80% of the nitrogenous compounds in whey are denatured and co-precipitated with casein when the pH of the heated milk was adjusted to 4.6. So Roland observed that when you are heating the milk or boiling the milk, then 80% of the nitrogenous compound in the whey were denatured, and these were co-precipitated with the casein when the pH of the heated milk was adjusted to pH 4.6. Now this heat denaturable whey proteins represented the lactoglobulin and lactalbumin fractions, and the remaining 20% were designated as protease peptone. Now these protease protein fraction also, which is quite heterogeneous, is also can be precipitated by 12% TCA. So here written is that if you are using 12% TCA, then this protease peptone fraction can also be precipitated. But there are some nitrogenous compounds which remain soluble in 12% TCA, which are designated as non-protein nitrogen. लेकिन कुछ नाइट्रोजन कंपाउंड्स हैं वो जो फिर भी सोल्यूबल रह जाते हैं जब हम 12% TCA का यूज़ करते हैं, और उसको उन जो सोल्यूबल नाइट्रोजन कंपाउंड्स हैं उनको NPN फ्रैक्शन को डिनोट करते हैं. तो ये आप देख सकते हैं स्लाइड पे, आपने रोलैंड स्कीम दी हुई है क्वांटिफाइंग प्रिंसिपल फ्रैक्शन इन मिल्क. तो हियर 3 लाइन्स आर रिटन दैट Roland in 1938 defined the conditions and procedure for a scheme to analyze the milk protein fraction. So by this procedure we can casein, albumin, globulin, protease peptone and non-protein nitrogen can be fractionated. तो इस प्रोसीजर से हम कैसिन, एल्बुमिन, ग्लोबुलिन, प्रोटीज पेप्टोन और नॉन प्रोटीन नाइट्रोजन को फ्रैक्शनेट कर सकते हैं. So determination of these fractions can be denoted systematically based on nitrogen estimation by Jaldal method. Okay, so this is the scheme which is given by the Roland. So here if we start from skim milk, skim milk is obtained by removing fat from milk, that we have the skim milk, and if you are determining the nitrogen content in skim milk, that is designated as Jaldal 1 nitrogen. Okay, then you acidify the skim milk to pH 4.6, you will have casein get precipitated and you have known casein nitrogen in the filtrate, and this known casein nitrogen will consist of serum proteins and non-protein nitrogen, and you designate it as Jaldal 2 nitrogen. Okay, now you saturate this filtrate or the whey with magnesium sulfate. You will have globulins get precipitated, that is called as Jaldal 5 nitrogen. Your globulins will get precipitated, and in the filtrate you will have albumin and non-protein nitrogen. Now on the other side, if you are heating the milk at 100 degrees Celsius for 20 minutes, that you are boiling the milk and then acidifying the pH to 4.6, we have already seen in the previous slide that your casein and heat levels and protein will get precipitated, and in the filtrate you will have the protease peptone and non-protease nitrogen, which is designated as Jaldal 4 nitrogen. Now and then in another way what you can do, you can precipitate the skim milk using 12% TCA. You precipitate the skim milk using 12% TCA, and then you will see that all the proteins will be get precipitated. So all proteins in milk can be precipitated by using 12% TCA, and in the filtrate you will have the non-protein nitrogen, which is designated as Jaldal 3. So here we can see that in the flow chart we can see that different nitrogen fraction of milk has been fractionated by the scheme given by the Roland. So total nitrogen in Jaldal 1, here it is written total nitrogen in Jaldal 1, non-casein nitrogen in Jaldal 2, that is obtained by adjusting the pH of the skim milk to pH 4.6, non-protein nitrogen in Jaldal 3, that is obtained by treating the milk with 12% TCA, and then NPN and PPN is equal to Jaldal 4 nitrogen. So Jaldal 4 nitrogen is there in the that consists of protease peptone and nitrogen and non-protein nitrogen. Here it is, and then comes the lactoglobulin nitrogen, that is Jaldal 5. So here it is lactoglobulin nitrogen. So we can see that different nitrogen fractions can be obtained by using the scheme given by the Roland 1938. So these are the fractions which are obtained. So total nitrogen was there in the fraction 1, and the nitrogen content was observed to be that if 540, then 540 milligram nitrogen per 100 ml is there in the nitrogen content, the total nitrogen. If you see now, casein nitrogen will be equal to 1 minus 2. So if you see here in the previous slide, that 1 minus 2, if you remove 1, this is 1, from 1 nitrogen which is obtained, you remove the second nitrogen, you obviously will have the casein nitrogen. So casein that is casein nitrogen equal to total nitrogen minus non casein nitrogen. So that is around how much? It is 430 milligram nitrogen per 100 ml. Then comes the albumin nitrogen. Albumin nitrogen will be obtained by 2 minus 4 minus 5. So here if you see that here we have 2 minus 4 minus 5. So if you remove that proteus to non-protein nitrogen as well as the globulins from the non-casein nitrogen, then you will have the albumin nitrogen. Okay, so albumin nitrogen is equal to 2 minus 4 minus 5, and that is equal to the 43 milligram nitrogen per 100 ml. That much nitrogen was there in the, that is observed by Jaldal method. Then comes the globulin nitrogen. This is, as we know, I have already told that if you are treating the Whey with acetylate magnesium sulfate, then you will have the precipitated globulin nitrogen, that is designated as Jaldal fraction 5, and then milligram nitrogen per 100 ml is 19. Okay, then comes to the proteose peptone nitrogen, that is equal to 4 minus 3. So how it is 4 minus 3? You see in the 4 you have proteose peptone and non-protein nitrogen in the Jaldal, and your 3 is non-protein nitrogen. So obviously, so if you remove third nitrogen third from the Jaldal, you will have the proteose peptone nitrogen. Proteose peptone nitrogen plus NPN minus NPN will be equal to proteose peptone nitrogen, and that is how much nitrogen was observed, that is 18 milligram nitrogen per 100 ml. Okay, then comes the NPN, that I already told that if you are treating the milk with 12% TCA, then all the protein fraction get fractionated, and the non-protein nitrogen which is there is designated as non-protein nitrogen and Jaldal 3, and nitrogen content observed in NPN is 30 milligram nitrogen per 100 ml. And if you want to calculate the percentage of total nitrogen, so total nitrogen, if you take 100%, then you can calculate 30 by 440 is 79.5 percentage, 43 divided by 440 is 8 percentage, and 19 by 540 is 3.5 percentage of the total nitrogen. 18 by 540 is equal to around 3% of the total nitrogen. 30 by 540 is equal to the 5.5% of the total nitrogen. So we have seen that how to fractionate different nitrogen fractions of the milk using the Rowland fractionation scheme. So this way we can fractionate. Thank you.